Dear students, today again we'll revise your velocity time graph and I'll be discussing three cases for your velocity time graph. So case 1 is if a body is in motion with uniform velocity. First case is for uniform velocity. Now what do you mean by uniform velocity? That in this case velocity remains constant with time. Now what will be the nature of a graph for uniform velocity? So you can see here I am plotting this VT graph. I've already told you that time axis we take along x-axis and velocity is taken along y-axis. And we know unit for representing velocity is meter per second. So always remember, when we have to plot velocity time graph for a uniform velocity, it always comes out to be a straight line parallel to time axis. Comes out to be a straight line parallel to time axis. Now I'll explain you how it comes out to be a straight line parallel to time axis. Let us say that the body is moving with certain velocity, and let us say that at time t is equal to 1 second, the velocity of a body is 40 meter per second. Means at time 1 second, velocity is 40 meter per second. Then as time increases, let us say 2 second, again the velocity of a body is 40 meter per second. For time 3 second, again velocity is 40 meter per second. For time 4 second, again the velocity is 40 meter per second. So when I join the coordinates, it comes out to be a straight line parallel to your time axis. Means the velocity remains constant. Students, remember in this case, for uniform velocity, your initial velocity of a body is equal to the final velocity of a body. As we all know, acceleration is equal to v minus u upon t. If initial body velocity is equal to your final velocity, in that case acceleration will come out to be 0. So for your uniform velocity, a is always equal to 0 meter per second square. You have to learn this thing, that if someone asks you what is the value of acceleration for uniform velocity, then you can say that the value of acceleration will be equal to 0 and graph will be a straight line parallel to time axis. Now students, second case is uniform acceleration. It means if body is in motion with uniform acceleration. What do you mean by uniform acceleration? It means equal change in velocity in equal interval of time. Equal change in velocity in equal time. So when we have to plot your VT graph for uniform acceleration, remember it will come out to be a straight line, right, along your time axis. Now we know time is taken along x-axis and velocity is taken along your y-axis. So this is the kind of a graph you'll get for uniform acceleration. Remember, in uniform acceleration, v is always greater than your u, where v is your final velocity and u is your initial velocity. I'll explain you this graph again. Let us say that for time t is equal to 1 second, the velocity of a body is 5 meter per second. For time t is equal to 2 second, let the velocity is 10 meter per second. As time increases to 3 second, velocity also increases to 15 meter per second. Let it say. For time t is equal to 4 second, velocity is equal to 20 second. So for each 1 second, the increase in velocity is 5 meter per second, right? So this statement applies that equal change in velocity in equal interval of time. For every 1 second, change in velocity is 5 meter per second. So this is a kind of a graph which we obtain when a body is is in motion with uniform acceleration. Now third case is uniform retardation. Means if a body is in motion with uniform retardation. What do you mean by uniform retardation? It means that velocity of a body decreases as time increases. So what will happen when we have to plot a graph for your uniform retardation? This is a VT graph. Time, again I'm repeating, time along x-axis and velocity along y-axis. So the graph obtained for the motion of a body in uniform retardation is a straight line inclined to time axis but with a negative slope. So this is a kind of graph which we obtain for a body moving with uniform retardation. Remember students that in this case, as we know the slope of VT graph, you have to learn this thing, the slope of VT graph gives your acceleration, right? And in this case, acceleration is coming out to be negative, as in it is a retardation. So for this retardation, remember V is always less than U. Means your initial velocity is always greater than final velocity, or you can say final velocity is always less than initial velocity. So if we apply the formula, A is equal to V minus U upon T, if this initial velocity is greater, then A will come out to be negative. So this is a graph, VT graph for uniform retardation. Next topic is your acceleration time graph, and this is also very important for examination point of view. Now for acceleration time graph, first I'll tell you, we take time along x-axis and acceleration along y-axis. What we can calculate from your acceleration time graph? So dear students, remember that we can find change in speed in certain interval of time from your acceleration time graph. Now we have three cases. I'll be discussing three cases how we can plot acceleration time graph. So this is a case 1 for your acceleration time graph. First case is when a body is stationary or body is moving with uniform velocity. Now just try to understand students that when the body is stationary, in that case means the body is in rest. In that case, your initial velocity is equal to 0. Remember, initial velocity u is equal to 0. Second, this is the first case only, or it may happen that body is moving with uniform velocity. Now, what do you mean by uniform velocity? I have told you that equal velocity changes with equal interval of time. So you can say that initial velocity u is equal to final velocity, and that is not equal to 0. Means initial velocity is equal to final velocity. Now remember, you have to just remember simple thing, when a body is moving not moving, that in that case your u will be equal to 0, and when the body is moving, in that case your final velocity will be equal to, or there is certain change in velocity, right? Then we know the formula that A is equal to V minus U upon T. For first case, when a body is stationary, your U is 0. Your U is 0 and U is 0. So V will also be 0 because the body is not moving. So we can say acceleration in that case is 0. For second case, if a body is moving with uniform velocity, we know that V minus U upon T is a formula for acceleration. In this case, U is equal to V. So U minus U upon T, that comes out to be again equal to 0. So acceleration in both the cases is equal to 0. Now how we can plot graph for this situation, for this case, remember for this case we take time along x-axis and acceleration along y-axis. So acceleration time graph for such a situation will be a straight line which will coincide with the time axis. So this will be a kind of graph obtained for your body when it is stationary, or for a body when it is moving with uniform velocity. So it will overlap along time axis. Now second is the case when a motion of a body is uniformly accelerated, means velocity increases with time. As velocity increases with the time, so we can say that final velocity is greater than your initial velocity. What about acceleration? Again, we'll apply the formula A is equal to V minus U upon T. At final velocity is greater, so acceleration will be positive, right? So what will be a kind of graph obtained for a body which is uniformly accelerated? Remember students, for a body in motion with uniformly acceleration, the graph will be a straight line parallel to time axis above your origin. So this is a kind of graph. Let us say this is a straight line PQ. This is a kind of graph obtained for uniformly accelerated motion. Now third case is motion is uniformly retarded. Now what do you mean by retarded motion? It means that velocity decreases with time. So in this case, your final velocity will be less than your initial velocity. Again, I am reminding you people that we represent your final velocity and you represent your initial velocity. And what about acceleration? Same formula, V minus U upon T. So as you know that final initial velocity is greater, so acceleration will be negative. And we know negative of acceleration is your retardation. So the graph obtained for your uniformly accelerated motion will be again a straight line, but as we all know acceleration is negative, so it will be below your origin. For accelerated motion, it will be a straight line parallel to time axis above origin, and for retarded motion, or you can say deceleration, it will be a straight line below your origin. So this represent your accelerated motion and this represent your retarded motion. Means the point, the slope of the line below your time axis represent retardation and above represent acceleration.